I'm going to show you how to use the graphing calculator to help you find time when the exponent is the thing that's missing. Sometimes it's hard to figure out that number. We will learn a way when we talk, once logs are introduced, we'll figure out a way to solve for t, but until then you need to probably use a graphing calculator to be able to answer a question like this. So the scenario is that we are starting with $2,000 in our account. It's got an interest rate of 4%. It's increasing by that much each year. And the question is how many years, so we're missing the time, how many years will it take to have $3,000 in the account? So $3,000 is the final amount. So let's put all the numbers in the right spots. We have our final amount is the big A, or the A of t if it's in function notation. So we'll put 3,000 here. A is the starting amount, which was 2,000. Then we're increasing by an interest rate of 0.04, so our rate is 0.04, and since it's increasing we put plus, not minus. And then t is the thing that we don't know. So it would be very difficult to solve this for t without using the graphing calculator. So let me show you on the next page what we'll do. So we're going to end up graphing this on our graphing calculator as a function that we can then solve for. So what we want to do is we want to get 3,000 off of this side, and the only place we can put it is basically at the end there, and so that will give you a 0 here, and then 2,000, 1 plus 0.04 to the t power minus 3,000. Now you're going to put this into the y equals part of your graphing calculator, and what we're going to be finding is the 0 of the function, or a x-intercept. So when y is 0, you're on the x-axis. So we're looking for when this function is going to equal 0, which means when it's going to hit the x-axis. And so what I want you to do is take the y equals button and put everything else in there besides the 0. Once you hit the graph button and hit zoom, it should look something like mine. Now keep in mind the way zoom works is you just hit zoom 3 if you want zoom out. It's better to hit the number 3 rather than scrolling down to 3, because then when you push enter one time it will work. Now if that doesn't work, or you forgot to push the number 3 and you scrolled down, usually if you just push enter again it will continue the zoom out process. So if it doesn't look like it did anything, just try pushing enter again, and usually the zoom will happen. The reason we had to zoom is because we had to be able to see the x-intercept, and we could not see where it was crossing the x-axis when it was in its original graph before we zoomed. So what you're trying to get the calculator to do is to find this x-intercept. And whenever you do second calc number 2, what you're asking it to do is to find the x-intercept. Now what that calc is above the trace button, so you do second calc to get to it, and then 2 is the choice 0 under the menu that comes up, and this means we're finding the 0 of the function, which means we're finding the x-intercept. So anytime you want to find the x-intercept, you're looking for that function called 0, which is found in second calc number 2. So after you hit second calc number 2, it should pop up on your screen left bound question mark, and so what it's asking for is the left boundary, because it wants to know, in case there was lots of x-intercepts, which one you're wanting to find, and so it always makes you put a left boundary and a right boundary on it. And so you're just going to have to deal with that by looking at the x and y values at the bottom of the screen. And as you move left, so you're going to do the left arrow and you're going to move left, just make sure that your x value is something to the left of wherever that is. So if it's very, very small or maybe negative, you know it's to the left of it. So after you think that x value looks like it's to the left of that x-intercept, then say enter, and it will put a little arrow at the top that represents the left boundary. Then you do the same thing. It asks for right bound, so you just start arrowing to the right, and arrow, arrow, arrow to the right until you kind of see the cursor passing through the x-axis, and then it will be above the x-axis, which in this case you can kind of see the way the line is slanting. The line is slanting a bit this way. I know I'm making it extreme, but it's slanting a bit this way. So you want your right bound to be over here, and your cursor would be then above the line, the x-axis. And so your left bound, you're going to be down here somewhere, and you may or may not see it, but just pay attention to those x and y values at the bottom. If the x value is very, very small, it's probably to the left of it, and as that x value gets bigger and bigger, eventually you're going to be to the right of it. If you miss the first try, then you'll see that your left bound and right bound are not on either side of the x-axis. If your left and right bound aren't surrounding the x-axis in a sense, then you know you need to start over and just hit second calc 2 again, and then try to get your left and right bounds on either side of the x-axis. I mean the x-intercept, sorry. So then on the after you pick your left bound and your right bound, it'll always say the word guess, and you can always skip that step and just hit enter, and it'll pop up a screen that looks like this. So the word that has to be at the bottom of your screen is the word 0, and that means it's found the 0 of your function. The x-intercept is at 10.338 approximately, and so that is the spot where y is 0. And you'll see y is 0 here. Also, you could see some weird number like 5e negative 14 or something weird like that. If you ever see that e thing, it probably is just a tiny, tiny bit of an error in the calculator, and so you can assume that that equals 0. Technically, what it means is that it is 5 times 10 to the negative 14th. It's just scientific notation. And if you think about how small that number would be, you'd be moving the decimal point 14 places this way, and it'd be 0.000000, you know, a bunch of zeros and then a 5, which is very, 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 very tiny. And so that little tiny bit of error will show up on some of the calculators, and so just ignore it and know that anything that looks like this is just 0. So anyways, the y is 0 when the x is 10.338. So the x-intercept is 10.338, and then let's remember why we were finding that in the first place. So this was the original function we put into the calculator, and we just put an x there when we were putting it in the graphing calculator, and we put a y there, and we were trying to find out when y is 0, what does x end up being? Well, this is what x ends up being when y is 0. And so that solves the equation that we had. And so that means time that it takes to get the $3,000 in our account is 10.338 years. And so depending on what they wanted you to do with that, you could say approximately 10 years before you're going to have that money in your account.